Among the worlds of the solar system, there is one moon that for years has attracted the attention of scientists as one of the most promising places in the search for life beyond Earth. Its name is Europa. Europa is an icy moon of Jupiter and is one of the few celestial bodies outside our planet for which there is solid evidence of the presence of liquid water. And, as far as we know today, liquid water represents one of the fundamental requirements for life. The possibility that living organisms could exist in the oceans hidden beneath Europa's surface is one of the most fascinating hypotheses of modern astrobiology. To investigate this possibility, NASA has launched a new space mission, Europa Clipper. In the coming years, this spacecraft will reach Jupiter's moon with the goal of studying it in detail and determining whether it truly possesses the conditions necessary to host life. But what is currently known about Europa? And what information will the Europa Clipper mission be able to provide? Europa is one of Jupiter's moons and is part of the 4 large Galilean satellites discovered by Galileo Galilei at the beginning of the 17th century. It has dimensions similar to those of Earth's moon and lies at a distance from the Sun that makes it an extremely cold environment. Temperatures on its surface reach about minus 160 degrees Celsius. When observed from the outside, Europa appears as a world entirely covered in ice. However, one of the most important discoveries of 20th century space exploration was the possibility that, beneath this icy crust, a vast amount of liquid water may exist. The sunlight that reaches Europa is about 25 times weaker than that which reaches Earth and is not sufficient to keep water in liquid form. The necessary source of heat instead comes from the intense gravitational interaction with Jupiter. Europa always shows the same hemisphere toward the planet, but Jupiter's extremely powerful gravitational field exerts different forces on different parts of the moon, continuously deforming it. In addition, Europa's orbit is not perfectly circular, and its distance from Jupiter varies slightly over time. The result is a continuous process of compression and stretching of the moon. This deformation generates internal heat through a phenomenon known as tidal heating. According to theoretical models, the heat produced by this process is sufficient to keep a large amount of water in liquid form beneath the surface. The ice crust may be about 10 kilometers thick, while the underlying ocean could extend to depths greater than 100 kilometers. If these estimates are correct, Europa could contain a quantity of liquid water equal to, or even greater than, that of all Earth's oceans combined. The internal heat could also fuel volcanic activity on the ocean floor in a manner similar to what occurs on Earth. These submarine volcanoes could provide energy and fundamental chemical compounds, creating an environment potentially favorable for the development of life. In other words, beneath Europa's icy surface, all the ingredients considered essential for life could be present. Liquid water, a source of energy, and carbon-based chemical compounds. However, the presence of favorable conditions does not automatically imply the existence of life. Directly studying Europa's ocean represents an enormous technological challenge. Penetrating an ice crust several kilometers thick is, at present, beyond our capabilities. Moreover, even if life did exist, it would likely consist of simple forms, such as unicellular microorganisms. Reaching Europa's surface alone is extremely complex. The moon lacks an atmosphere capable of slowing a descent and is immersed in Jupiter's powerful magnetic field. This magnetic field produces an intense bombardment of charged particles. Radiation levels on Europa's surface are thousands of times higher than those on Earth, sufficient to be lethal to a human being within a few hours and to severely damage any electronic equipment. Despite these difficulties, there are clues that make it possible to study the subsurface ocean without drilling through the ice. Observations from the Hubble Space Telescope together with data previously collected by the Galileo mission, suggest that geysers may originate from Europa's surface. Jets of water vapor expelled into space through fractures in the icy crust. A similar phenomenon has been observed on Enceladus, a moon of Saturn, thanks to the Cassini mission. In that case, the spacecraft was able to directly analyze the material expelled by the geysers, obtaining valuable information about the subsurface ocean. It is precisely on this principle that a fundamental part of the Europa Clipper mission is based. Europa Clipper is the largest spacecraft ever built by NASA. Its size and structure were designed to protect its scientific instruments from the intense radiation generated by Jupiter's magnetic field. To limit radiation exposure, the spacecraft will not enter orbit around Europa, but will instead follow an elongated orbit around Jupiter, flying past the Moon about 50 times. During these flybys, Europa Clipper will descend to a minimum distance of about 25 kilometers above the surface. If geysers do exist, the instruments aboard the spacecraft will be able to analyze their composition, providing direct information about the underlying ocean. According to some theoretical models, this could make it possible to detect organic molecules and, in principle, even traces of biological activity. Even in the absence of geysers, Europa Clipper will be able to study the surface ice, which may contain material brought up from the interior due to the continuous deformation of the crust. The spacecraft is also equipped with a radar and a magnetometer, instruments that will allow scientists to study the subsurface ocean indirectly, estimating its depth, composition, and other fundamental physical properties. However, the results of this mission will take time. Europa Clipper will not reach the Jupiter system before 2030. When that happens, the mission will finally make it possible to study Europa in depth, determining whether this moon truly possesses the conditions suitable for hosting life and laying the groundwork for future exploration. In the future, even more advanced missions could land on Europa's surface, collect samples, and analyze them directly. And, with some luck, Europa Clipper could provide the first concrete clues to the presence of life beyond Earth. Even if no traces of living organisms are found, the mission will still allow scientists to better understand worlds radically different from our own and to expand knowledge of the possible environments in which life might arise in the universe. And this is precisely the deepest value of space exploration, understanding the conditions that make life possible and how far it may extend beyond our planet.